Good morning, students. Myself, Dr. Prasoon Hada. We were discussing last time metal atoms in biological systems. And today we will discuss what types of roles these metal ions perform in biological systems. Important roles of these metallical elements in biological systems. Firstly, regulatory action is exercised by sodium plus, potassium plus, Mg2 plus and calcium 2 plus. The flux of these ions through cell membranes and other boundary layers send signals that turn metabolic reactions on and off. The structural role of calcium in bonds and teeth is well known. Calcium 2 plus and zinc 2 plus bind the big protein molecular portion together that would otherwise be only loosely linked. An enormous amount of electron transfer chemistry occurs in biological system and it depends on metal containing electron transfer agents. These include cytochromes, Fe ferredoxin, which contains Fe, and a number of copper containing blue proteins such as azurin, plastocyanin, and stelacyanin. Metalloenzymes or metallocoenzymes are involved in great deal of enzymatic activity. Important metalloenzymes include carboxypeptidase, which contains zinc, alcohol dehydrogenase, which also contains zinc, and superoxide dismutase, which contains copper and zinc also. Urease, which contains nickel, and a cytochrome P450 contains Fe. All aerobic forms of life depend on oxygen carriers. These molecules carry oxygen from the point of intake, such as the lungs, to tissues. Their oxygen is used in oxidative processes that generate energy carriers. These are the following types. Hemoglobin contains Fe found in all mammals, hemoglobin found in various marine invertebrates, and hemocyanin, which contain copper found in arthropods and mollusks. Functions of elements on the basis of their action in biological systems. First, we take up metals. Commonly exist as metallobiomolecules and they occur as such. Metal storage and transport. Firstly, with celluloplasmin, it is a blue copper binding plasma protein. It exerts a catalytic activity, serum peroxidase, in plasma. It converts Fe2 into Fe3. Next is transferrin. Transferrin is an iron released from the mucosal cell. It finds portal blood mostly in Fe2 state. Fe2 is oxidized to Fe3 and then picked up by iron binding protein, that is transferrin. This protein is a glycoprotein of MW77000. It possesses two similar but not identical sites. It binds two atoms of Fe3 per molecule of protein to form a red ferric protein complex. Next is oxygen binding metallobiomolecules. Hemerythrin. It is a non-heme oxygen binding iron protein. It employed in great variety of marine worms and phyla of marine invertebrates. Iron 2 binds oxygen reversibly and when oxidized to iron 3 methenmerythrin, it shows no tendency to bind oxygen. Next is hemoglobin and myoglobin. Hemoglobin and myoglobin. Iron porphyrin complexes, hemoglobin and myoglobin, provides functions of oxygen transport and storage. The iron in hemoglobin and myoglobin always exists in +2 oxidation state. Oxygen molecule coordinates to Fe2 from one end of heme molecule. Globin proteins, the Fe2 to be oxidized to Fe3 by creating a hydrophobic environment so that water molecule could not reach the site. Hemocyanin. It possesses copper and bind one molecule of oxygen for every pair of copper 1 ion. Unbound hemocyanin is colorless. When oxygen binds to hemocyanin, it color is blue. They are found only in mollusks and arthropods, crustacea and arachnids. That's all, students. Thank you.